Hello all. In this video, we see the visual representation of radius of curvature. The radius of curvature is visually represented as radius of osculating circle as imaginary circle that fits specific point on the curve most strongly. That is the visual explanation. Imagine the curve and the non-linear path, then the curve, the line you are interested in, such as a road, parabola, or an arc, etc. The specific point, choose any point along that curve. So oscillating circle, at that exact point you can imagine a perfect circle that shares both the same tangent line and the same rate of bending as the curve itself. This best fit circle lies on the concave side of the curve. So, from this, the radius of curvature, the imaginary oscillating circle is the radius of curvature at a point P. The center of circle is called center of curvature. For a visual relationship as the tighter bends and gentle curves. So we have to see the tighter bends where the curve bends sharply, the oscillating circle is small, the resulting in small radius of curvature, where then gentle curve is the nearly straight and the oscillating circle is very large. This visual representation of varying radii of curvature along the path helps illustrate how a single curve can have different degrees of bend at both different points. Here, from in this diagram, shows curve and radii. Diagram illustrate curves with varying radii, highlighting how the radius of curvature quantities curve sharpness crucial for analyzing path dynamics in engineering and physics applications. Next, we see the radius of curvature in a road and railway design. Let us see the radius of curvature in a road and a railway design. The radius of curvature in a road and railway design is the radius of circular arc that forms a curve, which is critical for determining the design speed, ensuring passenger and vehicle safety. So, the managing forces like centrifugal acceleration, a smaller radius indicates a sharper curve which requires a lower speed, while a longer radius allows for higher speed. It is used to calculate the necessary super evolution to contracted the centrifugal force. It designing safe curves for vehicles, speed and safety. The radius of curvature directly impact the maximum safe speed for a road or a railway line. A smaller radius necessitates a slower speed to prevent accidents. Centrifugal force management. It is used to calculate the centripetal force needed to keep vehicle on track, which is achieved through super elevation. Design and consideration. Minimum radius. A minimum radius is established for different type of roads and railway lines based on factors like the design, speed and terrain. In roads, the radius of curvature determines the geometry of curve, and the necessary super elevation is called to allow vehicle to turn safely at a design speed. In railways, the radius dictates the importance of smooth curves. Radius of curvature in track designs, and the diagram represent the curve in railway tracks. Next, we see application in optics. We will see in next video.